Bronson setting up the robot here. That's little Robbie right there.
Robotics. I'm not getting any power here, old boy. What's going on here? You gonna be working as NS. You go home.
Great, Miss Edna.
You can do your graphics with it. The spinning alone was that in it. Do my thing, let me do my thing.
That is the brain of the mastermind right there. That is his mold.
Stop being foolish, boy. Stop being foolish. Master switch.
Let's investigate the robot.
Actually, I put it on the floor so she can run. She can run and jump like a true pet. Yeah. Crikey! Look at that, one of these robots from the Bahamas. Robots from the Bahamas. You gotta creep on a robot. Creeping on the robots. Come
The Matrix is here.
Watch out, make sure that the cameraman doesn't get beat down for stepping on the robot. Yo. Matrix reloaded. See that? Alright, now. So the computer's loading up. And them crikey crocodiles. The yellow. Oh my god, look at it. It's a yellow robin. Hey, that face me so jokey. Did I change anything in the application? Oops, error. Yep. Oops. Actually, gotta kill that. Okay. Alright. Now, pretty much the robot is comprised of the base controller called low level. And this was written on top of another class called Servo Controller that directly talk to the serial port. Anyway, low level was written on top of Servo Controller, and pretty much what it does is talks directly to the servo controller and supplies the exact servo and the exact coordinate of the servo position that the servo should spin to, which would in total give the robot its movement and make the robot look like it's moving and doing certain things. So pretty much servo controller based off of low level is simply a way that I could add that shit. I don't know what I said. Alright. Low level class that is the brains behind the actual servo controller. It sits on top of servo controller, a class that was written to talk to serial ports and passes over a 3-byte scheme. The first byte being for the servo, which servo you want to control. The second byte for the what a second, I forget. Let me open that up. What the hell am I doing? Okay, I need 1 byte for the address, 2nd byte for the value you pass into it, What the third byte for? Okay, I know what it is. There it is. Okay, pretty much this is the low level. This is the low level class. It sits on top of servo controller. That is that helps us to talk to the robot through the serial port and talk to the SSC serial controller, as you can see on the robot itself. Pretty much this class was written in conjunction with the 3-byte scheme that has to be sent to the servo controller. The 3-byte scheme being the first byte is a sync marker, the second byte is the actual servo number, and the third byte is the position. Now, the position on the actual, the position that's passed into the servo controller pretty much is the rotational coordinate of that servo out of 360 degrees. Therefore, giving us the robot, its movement and its life, and pretty much is just servos spinning at a particular rate or speed. All the functions, all the base functions were designed in this class. As you can see here, like spin base left and spin base right, pretty much all we do is call a function at a set position, seeing that scon is of type servo controller. There's a function in servo controller called set position, and pretty much set position accepts a numeric value for the servo number and then its rotational coordinate. And pretty much all of the functions were designed out of using set position, and in conjunction with what exactly the robot has to do. Okay, cut. This was the first application, the first major application that was written on top of low level to test whether or not our functionality was correct. Pretty much you can see all of the functions of the robot itself, like the gripper, the wrist, the elbow, shoulder, and pivot, and these buttons allow, its respective movement, like close and open for the gripper, of course. The ink value, the incremental value, pretty much sets the rate at which you want the particular all right, pretty much. The command controller was the first application that was written on top of low level, and we pretty much wrote this to give better control over testing some of the functionalities of the robot. As you can see, the robot arm controller has these different functions that it can do: pivot, shoulder, elbow, wrist, gripper. These are the various joints on the robot, and with these buttons you pretty much have control over all of these joints here. The ink value or incremental value pretty much sets in what incremental values would you want the robot to actually do each particular function. Like 5 is a pretty low number, so that you can actually you have better control, and the movements won't be so quick. So the lower the number, the slower the movements; the higher the number, the quicker the movements. And set pretty much just sets that increment value. Now the actual motion of the base with the wheels and all the turning and all that stuff is pretty much controlled at the bottom here, and the increment value in the middle pretty much is your speed set value. If you increase this, your movements are going to be quick, so we sort of leave that to 5, a low speed, so to have better control over the robot. Reset and stop, of course. Reset, the robot has a sitting position that it usually that we like to begin from, and we usually go to that in the event that we want to start over. And then of course stop, with big and bold, because sometimes it gets out of hand. And that's that. This area here pretty much is to tell us exactly what's going on, which function the robot is executing at a particular point in time, so for troubleshooting purposes, as well as just knowing exactly what it's doing versus what it's supposed to do. Okay, let's turn this on. Okay, battery power is a little weak today, but anyway. Alright. Okay, this is our reset position. Pretty much, we like to start at this position. It's like a sitting mode, a wait period for the robot to start off on. And as you can see, the arm is at a relaxed plank and the gripper is open, ready to go. So now, what I'm going to do is to test that application that we wrote on top of low level. I'm gonna keep clicking on open and close so you can see pretty much what's going on with that. And it's opening and closing just as we have set it up. I'm going to go to the wrist functions and I click on the wrist up and down, and pretty much just keep pressing up and down, and it does all those functions. Do the elbow up, elbow down, move outward, inward, and I can pivot right, and pivot left. Now we're going to do some of the tests with the regular, your mobile functions, but first of all I'd like to reset it back to original value, and now we're going to start to move the base. Move forward. Now notice that the increment value is set to 5, so if I increase it again, it should go faster as it is doing, and faster, and faster. Hit my stop button to stop it from moving, and I'm good. I'm going to try to go backwards, and hit backwards again, and backwards again. Hit stop. Let's go forward, and then let's say I want to turn right, and it's turning right. And of course the increment value does play a part in it, so if I hit turn right again, it will go faster and faster, and pretty much that's your basic robotic function. Alright, left, stop it, and let's just go straight. And stop it again. Okay, I'm going to attempt to have this robot pick up this little plastic thing, whatever, and let's see how this goes. So to make it easy, as it is not the strongest robot in the world, but I will try. First of all, I'll attempt to move forward. Let's get to move forward, baby. Okay. Now, since I moved a little bit to the right, I need to adjust a little bit. Okay, so I'm there. Move. I'm not gonna move forward anymore because now I want to use my arm features. So I'm going to take my shoulder outward, like so. Now I'm gonna move my elbow down. Oops. I'm going to move my elbow up, sort of, and move a little bit more outward. Okay, move my elbow down a little bit, and that looks like I could possibly grab it at that particular point, because just remember that it has to stretch outward to grab, so I might be able to try it, so I'll try to grab it. And I grabbed it. And let's try to pick it up. And let's say that I wanted to drop it in my hand. First of all, I gotta turn left. And bring it forward. Okay, for this test, I'm gonna try to get the robot to pick up this plastic shape here. So I'm going to help it by lining it up, and hopefully it'll be able to pick up that shape right there. Alright, so let's start. Okay, we're going to attempt to have this robot pick up this plastic shape. So I'm going to put the shape right there. Oops. Make it a little easier for him to pick it up, because we just want to show some of the functionality. It's not the best structured robot in the world or whatever, but just to display that, you know, it has some sort of purpose. Let's try to pick this up. So first thing I'm gonna do, I'm gonna move forward toward the object. Right click and move forward. And I'll stop right there. Now I want to show off some of the arm features, so I'm going to extend the arm outward a bit. But actually, yes. Okay, now pretty much that should hopefully do it right there. So I'm gonna try to attempt to grab it and pick it up and then see what happens. Alright, picked it up on the first go, great. Now, I'm gonna pick it up. And turn it a little bit toward me. And seeing that I'm to the left of the robot, I'll turn left a little bit and hopefully we can get it to drop in my hand. And I'll move it forward. And now for the release. Well, it released it. I didn't catch it. That's my fault. But it works out pretty fine. Cut. That's cool. Like, welcome back. Welcome back. Now, I'm about to go into the speech interface a little bit, but before I do, I'd like to talk about it just for one quick second. Now, the speech interface was developed by Dr. Allen, and a grad student at Florida A&M University, and what they did was they made it extremely easy to develop in a GUI-based environment speech commands, and then you were able to take those classes and apply them to any Java programs. So basically what you would do in theory and concept was type in what you wanted to say in a graphical user interface and then tie that into a particular function that you wanted to do. Pretty much easy. That's all it was. It was an ingenious idea, and I hope one day Dr. Allen gets it patented. Alright. Now, cut. Alright, when I start going, I want you to go back. What I'm gonna do next is invoke the the speech interface program that we put on top of the low-level controller that we designed, and as you can see, it's executing, it's going into the COM ports, whatever like that, it's connecting, and now it's invoking the IBM engines. We use the IBM Via Voice speech libraries to create all the synthesis for the speech. You just heard it say, give me a command. Pretty much it's just waiting for a command for me to say. So, without further ado, there's the mic, and I will put this on the floor. And let's attempt to pull this off, as we all know how difficult speech interfaces are. Speak, and hopefully it'll work. Hopefully. Move. 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 Go. Move.
Give me a command.
Right. Move. Move. Stop. 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 Stop.
Give me a command.
Move. 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 Stop. 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 Move. Release. Go. Back. Turn left.
Give me a command.
Stop.
Give me a command.
Move.
Give me a command.
Stop.
Give me a command.
Back.
Give me a command.
Slower.
Give me a command.
Slower. Stop.
Give me a command.
Move. Stop. 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 Faster. Elbow up. Elbow up. Elbow up. Elbow up. I can start it up again. Elbow up. Elbow up. Elbow up.
Give me a command.
Elbow up.
Give me a command.
Move.
Give me a command.
Grab.
Give me a command.
Release.
Give me a command.
Turn left.
Give me a command.
Stop.
Give me a command.
Back.
Give me a command. Give me a command.
Slower.
Give me a command.
Slower.
Give me a command.
Slower.
Give me a command.
Stop.
Give me a command.
Move.
Give me a command. Give me a command.
Move.
Give me a command.
Reset.
Give me a command.
Reset.
Give me a command.
Move.
Give me a command.
Turn left.
Give me a command.
Stop.
Give me a command.
Back.
Give me a command.
Slower. Slower.
Give me a command.
Stop. 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 Stop.
Give me a command.
Keep rolling. Elbow up. Elbow up. Elbow up.
Give me a command.
Elbow down.
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 Give me a command.
Shoulder out. Shoulder out.
Give me a command.
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 Wrist up.
Give me a command.
Wrist up.
Give me a command.
Wrist up.
Give me a command.
Stop. Stop.
Give me a command.
Wrist up.
Give me a command.
Wrist up.
Give me a command.
Wrist up.
Give me a command.
Stop.
Give me a command.
Stop.
Give me a command.
Wrist up.
Give me a command.
Wrist up.
Give me a command.
Move.
Give me a command. Give me a command.
Stop.
Give me a command.
Move.
Give me a command.
Stop.
Give me a command.
Alright, let's try to pick this up. Reset. Reset.
Give me a command.
Turn right.
Give me a command.
Stop. 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 Stop.
Okay, Ross.
Stop. 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 Stop.
Give me a command.
Shoulder out.
Give me a command.
Shoulder out.
Give me a command.
Elbow up.
Give me a command.
Elbow up. Elbow up.
Give me a command.
Shoulder out.
Give me a command.
Shoulder out.
Give me a command.
Shoulder out.
Give me a command.
Shoulder up. Elbow up.
Give me a command.
Shoulder up.
Give me a command.
Elbow up.
Give me a command.
Shoulder up.
Give me a command.
Grab.
Give me a command.
Shoulder up. Elbow up.
Give me a command.
Elbow up. Elbow up.
Give me a command.
Stop.
Give me a command.
Elbow up. Shoulder out.
Give me a command.
Shoulder in.
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 Give me a command.
Elbow down.
Give me a command.
Elbow down.
Give me a command.
Shoulder in. Shoulder in.
Give me a command.
Elbow down.
Give me a command.
Elbow down. Shoulder in.
Give me a command.
Shoulder in. Elbow down.
Give me a command.
Turn right.
Give me a command.
Straight.
Give me a command.
Faster.
Give me a command.
Stop.
Give me a command.
Release. Release.
Give me a command.
There you got it. It works. Thank you.
A peek in the mind of Khary Sugar Boy Davies. Bronted one time. Bronto. This is the breakdown of the Bronto. The Bronto is comprised of 17 secret steps, herbs, and spices. And you cannot duplicate the Bronto. Khary is bronting it from all angles right here. Right here, folks. You've never seen it before. A Bronto caught on TV. Look at the Bronto! It's a Bronto! Okay, looks like the robot is still going on. Who left the laptop on? What is the Robbie the robot doing? Khary is playing with Robbie. Khary, crikey! That's one of them Bahamian robots right there. Crikey, man, mate, look at that. Tackle it, oh God, tackle it, oh. Stupid, man. He's looking stupid now, what a sick. Robotics at its finest right there. Crikey, it's one of them yellow African killer robots from I don't know where, from Zagunda. Yeah, crikey. Look at it. Look.
I got one of them, mate. Yes, I have it right here. Look, that's it.